This is Pre-Algebra, Chapter 9, Section 2, Simplifying Square Roots. Our goal today is to simplify radical expressions. Before we go into the notes, I would like you to pause this video, and I would like you to go to this poodle video and watch this poodle video. I love this poodle video. I think it is a great representation of simplifying radical expressions. Unfortunately, I tried to play it on the video for you here so we could watch it together, but it would not let me do that. So I cannot show it to you. You have to go watch it on your own, and when you are finished, come back and we will start the notes. Okay, welcome back. I hope you enjoyed the poodle video. It is an excellent representation of what we are doing here, and you will see that shortly. Okay, first thing, let's talk about the simplest form of a radical expression. The simplest form of a square root would simply mean that there are no more square roots inside the radical. You have removed and solved and simplified all of the square roots that were hiding inside that radical. Also, simplest form means that there are no radicals in the denominator. There cannot be any radicals in the denominator of a fraction. So let's take a look at example 1, simplifying a radical expression. First, I am going to go off to the side here and show you the poodle method. So we have the square root of 150. We want to simplify this radical expression. And simplifying a radical expression means leaving it in radical form. So because 150 is not a perfect square, there will be a radical in your final answer. So according to the poodle video, we have to prime factor this. What are two factors of 150? Well, we could do 15 and 10. Neither of those factors are prime, so we are going to continue with our factorization here. 15 is 3 times 5. Both of those are prime numbers. And 10 is 2 times 5. Both of those are prime numbers. So we have prime factored 150. Let's move over a bit. We are going to rewrite radical 150 as the product of its prime factors. So in numerical order, radical 150 does also equal radical 2 times 3 times 5 times 5. Now, if you recall in the video, when the police showed up, everyone with a partner grabbed their partner and escaped. Anyone who didn't have a partner went to jail. So in this case, the factors that have a partner get to leave the radical. 2 and 3 do not have a matching pair, so they have to stay inside the radical. So what we are going to do is cross off one of these 5s and move the other one to the outside of the radical, which means there is now 1 5 that escaped the radical, and we have a 2 times 3 on the inside, which simplifies to 5 times radical 6. 5 times radical 6. There is another way to simplify this radical expression. The poodle method, or prime factorization, is my preferred way to do this, but if I'm doing it in my head, I use the greatest perfect square factor method. So we're going to go over here and use the greatest perfect square factor method. So sometimes you can do these in your head, and you'll be able to think of two factors of the number inside the radical, one of which will be a perfect square. So think about it. Give me two different factors of 150, one of which is a perfect square. Did you get it? 150 can be broken into 6 times 25. Radical 150 equals radical 6 times 25. So if we use the product property of square roots, the product property of square roots tells us that every factor inside the radical can get its own house. It can get its own radical, so everyone gets a separate home. Social distancing, right? So we are going to socially distance these two factors. We know that the square root of 25 is 5 because it is a perfect square. Radical 6 cannot be broken down any further because its factors are 3 and 2, or 6 and 1, neither of which work, so he has to stay inside the radical, and your answer is 5 radical 6. Two different methods, two different sets of factors, same final answer. Let's try this again in example 2, but this time we've added a variable. So first, I would like to do this using the poodle method, using prime factorization. So let's rewrite over off to the side radical 18t squared. Now we need to prime factor. So I want to separate these so I can prime factor effectively. 18 times t squared. Now they're far enough apart that I can factor them. So 18 can break into 3 and 6. 3 is a prime number. 6 becomes 2 and 3. Both of those are prime numbers. Now if I factor t squared, I get t times t. Both of those are prime. Now let's rewrite what we have going on here. So instead of radical 18, I am going to rewrite it as radical 2 times 3 times 3 times t squared, which becomes t times t. T times t. Now the poodle method tells us to find the pairs and bring one member of the pair out of the radical. Everyone else goes to jail or stays inside. So who do we have as a pair here? We have a pair of 3's and a pair of t's. So what do we do? Cross out a 3, bring one outside the radical. Cross out a t, bring the other one outside the radical. So we are eventually left with 3 times t on the outside with a 2 left on the inside, which gives us a final answer of 3t radical 2. 3t radical 2. Now let's do this using greatest perfect square factors. So 18t squared. That can be broken down into perfect square factors. Two factors of 18 that are perfect squares. We have 2, which is not a perfect square, times 9, which is a perfect square, times t squared, which is also a perfect square in variable form. The product property of square roots tells us to socially distance these factors, put them in their own homes. radical 2 times radical 9 times radical t squared. What can we take the square root of here? We can take the square root of 9 because 9 is a perfect square. We can also take the square root of t squared because it's an even variable, or it's an even exponent, so we just take half of the exponent and move it out. The square root of t squared is t. So we are left with the square root of 9, which is 3, times the square root of t squared, which is t, and radical 2 can't be simplified. So we are left with radical 2. All right, so this is actually our final answer. If we were to simplify and then use the commutative property, that's what you would get. So let's simplify first, and then I'll use the commutative property. Radical 2 times 3 times t. You always want your coefficients with your variables to be in front of the radical, so we used the commutative property of multiplication to move the 3t in the front of the radical, and that would be your final answer, 3t radical 2, which is the same thing that we got over here using the prime factorization or the Poodle method. So let's come down here and complete this checkpoint. When you are ready, pause the video and come back when you are finished to check your answers. Here are the first 2 checkpoints without variables. I did both methods. So for number 1, the first method would be the Poodle method or the prime factorization method. You can break 75 into 3 times 5 times 5. There are a pair of 5s. 1 comes out. You are left with 5 radical 3. You could also use the perfect square factor method. 75 could also be broken into 3 times 25. When you give each of them their own radical, radical 3 stays radical 3 because it cannot be simplified. Radical 25 is a perfect square, so that becomes 5. Using the commutative property, you get 5 radical 3. 2 methods, same answer. Number 2, radical 80, using prime factorization, can be broken into 2 times 2 times 2 times 2 times 5. There are 2 pairs of 2's, so circle the first pair, take 1 out. Circle the second pair, take 1 out. That leaves you 2 2's outside the radical, and inside the radical is a 5. 2 times 2 equals 4. The final answer is 4 radical 5. Using the perfect square factor method, 80, radical 80, can be broken down into radical 5 times 16. Using the product property of square roots, everyone gets their own home. Radical 5 times radical 16. Radical 5 stays radical 5. Radical 16 is a perfect square. That becomes 4. Use the commutative property, and we get 4 radical 5. Come back for the last 2 with variables. Here are your last 2 checkpoint problems with variables. The first method, using prime factorization, radical 24 times r squared. You would prime factor that into 2 times 2 times 2 times 3 times r. Pull out one of the 2's, pull out one of the r's. You are left with 2 times r times radical 2 times 3, which gives you a final answer of 2r radical 6. If you use the perfect square, greatest common factor, you get 4 times 6 times r squared. 4 and r squared are perfect squares, so when you simplify, radical 4 becomes 2, radical 6 stays radical 6, radical r squared becomes r. Use the commutative property of multiplication, and you will get 2r radical 6, which is the same answer. Number 4, using prime factorization, we get radical 2 times 2 times 2 times 7 times m times m. There is a pair of 2's. There is a pair of m's. Bring one of each out of the radical, and you are left with 2m radical 14. Or use perfect